Hello everyone, welcome to a new clip in the C# for Beginners playlist. In this one, we continue where we left off in the previous lesson, inheritance, and we are going to talk about virtual methods. So first of all, let's understand what the problem is. Let's say we have a base class called animal, something like this. So we have the base class animal, which has a public method eat. Then we have two classes that inherit this animal class, cat and cow, and we create two instances of this class. Then we call the eat method on both of them because obviously they inherit it. And if I run it, we will see the message printed twice, which is great. But it doesn't offer us much information, does it? Because yeah, we see that the animal eats for each of them, but what the animal eats and how it eats, we don't actually know. Wouldn't it be nice to actually see something like a personalized message where cat hunts mice and cow grazes grass or something like that? This is where virtual methods come in. To declare one, all we need to do is to add a virtual keyword on the existing method. And now, since this is a virtual method, we can override it in any child class, like so. And if I run it, you will see that for the cat class, we get the customized message. That's again because the virtual method in the base class is overridden with a custom implementation in the child class. On the other hand, for the cow, since it doesn't override the virtual implementation, nothing changes. It's the same message that is the default in the base class. So think of it like this. Virtual methods allow us to override them in the child classes, thus offering us a custom implementation. But if we choose not to override them, they act sort of a fallback, so the virtual implementation will be used. Of course, we can also explicitly call the virtual implementation in the parent class using the base keyword like this. And I explained in the previous lesson that the base keyword means the parent, which means we can call anything on the parent class, including the virtual implementation. And now we get the custom message plus the default message in the parent. If you want a virtual method not to be modifiable anymore by further children of the current class, you can also use the sealed keyword like this. And in this case, as I explained in the previous lesson, sealed has meaning in the context of inheritance. You will not be able to override this method further. Still explained in the last lesson, I said that any data type in C# gets to inherit directly or indirectly from a base class called object. And I was showing you a few of the messages in this base class, like for example, get hashcode, ToString, and so on. But now you can also see that they are marked as virtual, which means we can override them in children classes. But to understand the issue, let's first declare a class. I declare a class with two properties, name and age. Then I create two instances of this class with different values for the properties. Then I'm trying to print, but not any of the properties of these instances. I'm trying to print the instances themselves. So if I run this, I will get a strange message. And in honesty, if I would have used a name, this would have been the fully qualified name. So the namespace plus the name of the class. But this also happens if I set a breakpoint and I hover the variables. I will get student. Why? That happens because since these instances each have multiple properties, name, age, etc., the program simply doesn't know which to choose in order to print on the console when we tell it to print the instance of the object itself. Doesn't know what to print from that object. So that's why it defaults to the fully qualified name, the namespace plus the name of the class. And that implementation comes from the virtual method ToString in the base class object. But since it's virtual, we can override it. And now we have a custom implementation of ToString where we tell what to print. If I run it now, we will have the name, comma, the age, the implementation that we said in the override of the ToString method. This also happens for the breakpoint. We can now see the customized message, and actually for the debugging side we could have achieved the same result by expanding and pinning what we want to see. See? So it's the same result. That's it for this lesson. Hit that like button if you found anything interesting in it, and you may also want to subscribe, because in the next lesson we will talk about the third pillar of object-oriented programming, polymorphism. And too bad it's not Halloween, because it's a good word to scare kids with, but as you'll see, there's really nothing to it. Anyway, until next time, thanks for watching, and I'll see you in the next tech frame.